Well, hello everyone and welcome back to our series on transport in humans. Now in this video, we'll be finishing up with the topic of blood. In the last video, we talked about organ donation and we talked about a problem that might happen in organ donation called tissue rejection. Now something similar to organ donation is blood donation. Right? Blood donation is where we take blood from one person, the donor, and we give it to another person, the recipient. Now, have you ever been for blood donation before? It's not an easy thing. It's quite complex. Right? They have to test and see whether your blood is a match with the recipient, whether or not you're able to donate to that person. Otherwise, there will be complications as well. There will be tissue rejection, as we will see in this lesson on blood and blood types. Now, the scientific word for blood donation is a blood transfusion. So a blood transfusion is basically taking blood from one person and putting it into another person. Now, the very first blood transfusion was carried out 300 years ago, as you can see in this picture here in black and white, except that it was carried out between a man and an animal. Yes, this man here is receiving blood from a lamb. Now, how do you think that turned out? Not very good. In fact, it ended up in death. You see, the man died because there was a problem. After the blood was transferred from the lamb into him, there was clumping, or what we call agglutination. Right? That's a scientific word for clumping. There was agglutination of red blood cells inside this man, and that caused him to die. Now, this actually is a form of tissue rejection. For you see, the man who was the recipient, the man, rejected the transplanted blood from the donor, which in this case was a lamb. Right? This man's immune system responded to the lamb's blood by producing antibodies, and it caused the blood from the lamb to clump together and caused this man to die, because there was lots of clumped up blood in his bloodstream. So this is actually a form of tissue rejection, resulting in agglutination of red blood cells. Now, what happened? What exactly caused this man to die tragically? Let's take a closer look at what happened in his blood. Now, this man's blood has red blood cells, right? In fact, all of us have red blood cells. Now, our red blood cells have special proteins on them. These special proteins are called antigens. Okay, so imagine that your red blood cells have antigens on them, special proteins. Now, these antigens are a bit like a school uniform. So what do I mean? The man, so imagine this is the man's blood. Okay, the man's red blood cells will have a certain kind of antigen to say that they belong to the man. So these antigens, the triangle-shaped ones, means we belong to the man. Okay, they're like a school uniform. Like when you wear your school uniform, you say that I belong to Newtown Secondary School. So this red blood cell is wearing this set of antigens to say that I belong to the man. Now in this man's blood, there are also antibodies. So in this man's blood, in his blood plasma, there are also antibodies. And the job of these antibodies is to detect foreign antigens, right? So these are antibodies, and their job is to detect foreign red blood cells that don't belong to the man. It's like, they are there to catch those students that are not from your school. Okay, they're there to catch students who are wearing other uniforms. You cannot come into Newtown Secondary School. Okay, so imagine now that there's the lamb's blood. Okay, so this is a red blood cell from the lamb. Imagine this is the lamb's blood, red blood cell. And notice that it is having a different kind of antigen on it, a circle-shaped antigen. So what happens when the lamb's blood is put into the man's blood? When I transfuse and donate the lamb's blood into the man, the antibodies automatically detect the foreign antigens. They're like, oh, these are not from the man. These are lamb's blood. This is a different kind of antigen that we have not seen before. So I need to detect it and I need to stop it. Right? So the antibodies will react with the foreign antigens, causing these red blood cells to clump together, which is what resulted in the death of the man. Okay, so that's just what happened. So importantly, you need to know what's an antigen, which is what's found in the red blood cell, and you need to know there are also antibodies which detect foreign antigens. Right, now we've learned about the basics of what happens in our blood. We can go on to learn about what exactly are different blood groups, right? And then what happens when we mix different blood groups together. So that's what we're looking at for the rest of this video. So what is your blood group? Do you even know what your blood group is? Maybe you know, you've heard before, there's O, A, B, and AB. Okay, and of course in Japan, when they draw these interesting comics, they seem to think that there's a link between your blood group and your personality, right? There's actually no evidence for that, very little at least. And importantly, there are 4 different blood groups. So you're either A, B, AB, or O. So what does that actually mean anyway? So what does your blood group mean anyway? Well, let's take a look first at blood group A as an example. So if you are blood group A, like me, I'm blood group A, that means that your red blood cells have antigen A on their surface. That means on your cell membrane of your red blood cells, they have antigen A. And inside your plasma, if you are blood group A, inside your blood plasma, or the serum, or the liquid part of your blood, there is antibody small b. Okay, so antibody small b detects antigen big B, which is not present in the blood cells of blood group A person. Okay, let's move on. You'll get clearer with more examples. Now, if you're blood group B, then your red blood cells will have antigen B on them. Okay, so in this case, I represent it with a circle. Okay, so blood group B, your red blood cells have antigen B on them. And inside the serum or the blood plasma of a blood group B person, there is antibody small a. Okay, so antibody small a detects antigen A, which is not present in the blood cells of a person who is blood group B. So now we move on to a person of blood group AB. So what do you think? Now a person in blood group AB will have both antigen A and antigen B on his blood cells, on his red blood cells. So now you can see both the circle and the triangle proteins, antigen B and antigen A. Now in his blood plasma and serum of a blood group AB person, they have no antibody A and no antibody B. Okay, so it does not have antibody A or B. Now why is this the case? Now imagine if this person had antibody B and antibody A in his blood. What will happen is that this antibody B will bind to antigen B, antibody A will bind to antigen A, and it would cause these red blood cells to clump together. Right? So if the person with AB had these antibodies in his blood, then basically the antibodies will attack his own cells and cause them to clump together. So that is why a person with blood group AB does not have antibody A and B in his blood. Right? So finally, for a person of blood group O, what do you think? Well, blood group O means that the red blood cells of this person have neither antigen A or B. So you don't see antigen A or B on the red blood cell. Now in his blood plasma or the serum, he will have both antibodies A and antibodies B. Alright? So at this point, it will be really helpful for you to do a summary for yourself. Let's say blood group A. What is the antigens present in blood group A? It has antigen A, right? And what are the antibodies in the blood plasma? You'll realize that he has antibody small b. So by now, hopefully you can see that antigen and antibody is a bit like opposites. If my red blood cell has the antigen, then my plasma will not have the antibody. Right? If my red blood cell has antigen A, the plasma has no antibody A. Otherwise, this antibody A will attack my own red blood cell. It's the same with blood group B, right? So blood group B, the red blood cell is antigen B. So the antibodies in the blood plasma is only antibody small a. Okay, there is no antibody B. If there was antibody small b, this antibody will attack my own red blood cells. So they are a bit like opposites. If I have the antigen, I will not have the antibody, and vice versa. Okay, complete the table by yourself. So now that we know about blood groups, we can finally talk about blood donation. Right? So for our first example, let's think about what will happen if we have a recipient of blood group O and a donor of blood group A. Okay, that means the recipient, who is blood group O, will receive A-type blood from this donor. Think about what will happen. Alright, so let's discuss it together, since this is the first example. Okay, here is the recipient's blood. Okay, so here is the recipient. He is blood type O. So his red blood cells do not have antigen A, do not have antigen B, and in his plasma, there's antibodies B and antibodies A. Okay, so the recipient's blood has antibodies A and B. Now let's introduce the donor's blood. So this is the donor's blood, and his blood type A. So here you see antigen A. Alright? Now what will happen is that, the antibodies from the recipient's blood, antibody A, will detect the antigen A and attach to it, causing all this donated blood, the blood type A, to clump together. Right? So this blood donation will be a failure. Alright? So antibody A binds to antigen A, causing clumping and agglutination. So this blood donation will fail, and this person of blood type O cannot receive blood type A blood. Right? So on our table, we can put it as such. If the recipient, here you can see the recipient, if the recipient is blood type O and the donor is blood type A, there will be clumping. So you put plus. Plus means there's clumping. Okay, but clumping means that this is bad. It will not work out. Okay, so even though this is plus, plus means clumping, but plus actually in this case is a bad thing because clumping is bad. This person cannot, O-type blood cannot receive from A-type blood. So let's look at the opposite case. In this case, the recipient is blood type A, while the donor now is blood type O. So let's look at the recipient's blood again. So in the recipient's blood type A, the red blood cells have antigen A, and the blood plasma contains antibody B. So now if we donate the donor's blood, okay, the donor's blood is blood type O, so the red blood cells do not have antigen A, do not have antigen B. What do you think will happen? Will these antibodies attack the donated blood? Well, in this case, nothing will happen, right? Because these antibodies B will not attack the donated O-type blood because the O-type blood does not have antigen B on it. So in this case, there is no clumping, and this is a successful blood donation, a successful blood transfusion. Right? So O-type blood can donate to A-type blood. And on our table, we can show in this way. If the donor is O and the recipient is A, there is no clumping and this is good. It's a successful blood transfusion. Alright, now I want you to go back and I want you to think about all these other cases. Just go and slowly think about it, like how I've taught you to do it. And I want you to fill out whether or not there's clumping or no clumping. And when we come back to class, we're going to discuss it together. Alright, that's all. I know it's been quite a long video for this week, but thank you for persevering. Okay, so just complete the table, and at the end of the day, think about this question. Which blood group is the universal donor? That means can donate to every other blood group. And which blood group is the universal acceptor that can take from all the other blood groups? Alright, see you in class.